Hi guys, Jayan this side. This is the sixth video of this playlist. This is specifically about sets. What is set? Different functions involved in set. In the last video, we studied about tuples. We studied they are immutable. We only use them for data which hardly or rarely changes. Okay. Now in this video, this is all about sets. So what is a set? Okay. What we'll study here? We'll study in this video basically about a collection. Think of it as a collection that automatically removes duplicates and makes lookups, like lookups when you're joining the two tables, lightning fast. Let's see how they work. Okay, first we'll talk about what is a set. A set is a collection of items that is unordered in nature, right, and always unique. It automatically throws away any duplicate. Understood? Okay. Think of a guest list where the same name can only appear once. Okay. No matter how many times you add it, you write a set in, okay, for that. So, how a set is defined? You write a set inside curly braces. Okay. Quick question, guys. How do you define a list? What brackets do you use? The answer is square. How do you define a tuple? Round brackets, right? Round brackets. Would that do? No. You have to mention comma, right? You have to mention comma in between. And how you identify this is a set? It is curly. It is curly. Okay. Now let me run this. Yeah, selecting the kernel. Kernel selected. Okay. So it says, yeah, it's printed out the list and it printed out the set and it says the data type is a set. Look at that. Okay. Look at that. What else it did? You, I put in duplicates, right? The set automatically collapsed them down and just one, two, three. Now, because a set is unordered, the items don't have position. Understood, guys? So, unlike a list, you cannot do set zero. Python will stop you. Correct? So, let me do this. If I do this, what will happen? It gives you an error. It says a set object is not susceptible. Okay. Yeah. So it means you can't order it, right? So it means no order means no position. So no indexing, right? So no indexing, right? Now the next thing we want to do here is to learn about adding and removing items. Okay. So there are four things you will learn here. Is first is the add. Okay, add one item. Okay, discard removes safely, no error if the item is missing. Right? If there is an item that is there, yes, you would have an error. Remove also removes, but it errors it will give you an error if the item is missing. Okay, so discard remove safely, that won't give you any error, and it if the item is missing. So you would always want to use remove, because if there is no item, what are you actually deleting or removing, right? And clear, again, just like it does to lists, it just clears it off. Okay, let me run this. Sorry, let me run that. Understood, guys? Yeah, so add, it added 4. Where it adds at the last. Discard, what is that? What is on the second index? 0, 1, 2. So it was 3. Sorry, sorry, on the second. So 0, 1, 2, 3. So it removed the second one. And then, sorry, not the second one, the value itself. And then it prints the S, whatever is left. Okay. So this is a nugget. Let me actually run this first. Okay, fast membership checks. Okay, what does it mean? So checking is this inside within within is extremely fast on set. Okay, so it's super lightning fast, much faster than a list when you have got a lot of data. That's the real superpower of sets. Okay, so if I run this, true, false. Understood? it's not making you won't sense a lot of super fast lightning speed now because it's just a very small set. But in general, it is very very fast, much faster than uh, list. Okay, now moving down to removing duplicate lists. Okay, okay. So here's the classic, most popular use of sets, removing duplicates from a list. You can turn your list into a set. Okay, so this is your list, right? You know how to define a list. Now it says you have defined this to a list. You are just saying set. Whatever is there in this, you are saying it as a set. That's it. And the what you call these duplicate names, this went off. Now, quick challenge. What do you think? Okay, we have S, okay, which is a set. We say add to print S. What it will give, guys? What it will give? Okay, let's see. It will give 1, 2, comma 3, and if we are adding by default, when it adds at the last. So if we run this, we should get 1, 2, 3, comma 2. Okay, let's see. Oh, we just got 1, 2, 3, what we gave in set. Why didn't we get an extra 2, guys? Why? Because set, set itself never keeps a duplicate. Remember, guys, it never keeps a duplicate. It never keeps a duplicate. Now, moving down to set operations. Okay, what are set operation? Okay, these are the main event set operations. These are called set operations. Set really so the set really shine when you compare two groups. That's the main super thing for that. Okay, so one second, guys. I'm getting a notification. Okay, yes, muted. Okay, so set. Imagine two friend lists. Okay, union, the bar symbol, ev everyone in either group. Intersection, the ampersand, on the people in both. Difference, the minus, in the first but not in the second. The symmetric difference, okay, the caret in one group but not both. Okay, so let me run this. Right? You understood, guys? This? How many of you understood? If there is any doubt in this, please post your doubt in the below group. So we had two sets, right? We had two sets. We unioned it, so we have these. We have intersection. What is common? What is intersection? What is common? What is the difference which we don't have? 1, 2, and 5, 6. 1, 2, and 5. Yeah, okay. Here it will just say 1, 2 because we are saying A minus B. Then we are saying symmetric, right? So it's giving the difference in both of the groups, right? Understood, guys? Okay. Quick challenge for you guys. So 2 and 3, okay. So we have a list here, sorry, a set here, which is x 1, 2, 3, 4, y 2, 3, 4. What's x and y? Take a guess. You can just have a look. What is this? Any guesses, guys? What's the answer? Is it 2, 3, 2, 3, 4, 1, 2, 3, 4? Okay, I'll help you. The answer is 2 and 3. Why? Why it's 2 and 3? Because the ampersand is the intersection. It tells you the commonality between both of them. Okay, so finding common friends. Okay, now putting okay, putting it together. Okay, like a real example, like I always do in my all of my videos. Find the friends people share and everyone's committed. Okay, you have to find two people. Okay, you have to find friends, two people share, and everyone combined. Correct? So my friends are Sam and Raj and Mia, right? And your friends are Raj, Mia, and Tom. what are the common friends, guys? Can I have a, uh, you know, can you tell me what are common? Raj, Mia, right? Raj and Mia, right? And what is everyone's? So it's Tom, okay, Mia, okay, then Raj, and then basically everything, but not just common. Common won't repeat, but everyone. Understood, guys? So that is really useful for a real world thing. Now, quick recap. Okay, quick recap we'll do here. So, what we studied up till now, a set stores unique, unordered items in curly braces, duplicates just vanish, no indexing, but very fast in checks, like one of the USP, unique selling points or superpower of sets, okay, for joining. Add and remove with add, discard, clear, remove. Turn a list into a set to remove duplicates, the operations and the operation union, intersection differences, symmetric differences. We learned all about that, right? In the next video, we'll talk about dictionaries, storing key value pairs. Okay. So see you guys in the next video. Thank you.